If I start with the sodium acetate, sure.
It's like the people in the group, they're not supposed to be different.
Yeah, yeah. It's simply because what it is, unless you people, both of you, just sit, print, take one and make a copy, that's not what I want, or that's not what I would like to see. You just go print it from your computer, you should have different number. Anytime somebody print it should come different number. Okay. Something we need to write down, because you need to, you actually, you can generate this yourself, but I'm gonna just we'll start with this is in your lab manual and actually in your lab report. So you're already given the data, mass of sodium acetate in the acetate buffer, volume of acetic acid in acetate buffer is given to you, mass of ammonium chloride given to you, volume of ammonium hydroxide given to you, and then the experimental results given. Now you go back and answer those questions here. And one thing I would like to get to you is, you have to write this down, molar mass of sodium acetate, which is CH3CO in A equal 82.03 gram per mole. Okay? Another thing you need to know, molar mass of ammonium chloride, NH4Cl equal 53.49 gram per mole. These numbers, you can do them, generate them yourself, but here's it is for you. The molar mass of sodium acetate, molar mass of ammonium chloride, because we're gonna use those numbers. Okay. In my experiment here, or in my lab work here, in my, I have the mass of sodium acetate equal 1.8600 gram. For you, it should be somewhere around 1.3719. That's my values. Okay, so I need to find from moles of sodium acetate. So moles of sodium acetate, CH3, CO, and A equal what? Mass over molar mass. So it will be 1.8600 gram divided by 82.03 gram per mole. And it will be, the number is 0.02267 moles. Something else you need to write down because you need it for your calculation. Now, the second thing they're asking, molarity of sodium acetate in the acetate buffer. So what's molarity? Moles over volume in liter. What's the volume of the solution we prepared? That's 250 milliliter, okay? The volume of the buffer we should have prepared if we were going to do the lab is 250 milliliter, okay? So volume, so molarity, molarity of sodium acetate, CH3CONA will be moles over volume. Will be 0.2267 moles over 0.2500 liters. We use 250 milliliter. That's why I'm using this data based on 250 milliliter. Okay, so that will be 0.9068 mole. So that's number one. I determined, or I found out, the molarity of this sodium acetate. Now I need to find the molarity, moles, and then molarity of acetic acid, because it's a mixture. So actually for you used volume of acetic acid is 3.49, molarity of acetic acid 3 molar, and you find the number of moles. So I used 3, and the molarity was 3, so I can go here, and I will say, okay, moles of acetic acid. I used 3, as you guys know by now, 3.0 milliliter divided by 1,000 to change it to milliliter per liter, multiplied by molarity. It happened to be the molarity also 3.0. And that's how it's given to us, 3.0. That's what it says. So we have only 2 significant figures here for the molarity. So for you means to find the molarity, number of moles, you have to multiply 3 times 3.49 divided by 1,000, and that will be 9.0 times 10 to the power minus 3 moles. You need to convert this to molarity, and then you take molarity of acetic acid will be moles over volume, 9.0 times 10 to the minus 3 moles over volume, which is 0.2500 liter, and that will equal 0.036 mole. These numbers are very important because you're going to use them for the further calculation. So you already now find the molarity of your buffer, which is a mixture of acetic acid. Here's the molarity of acetic acid, 0.036, and here's the molarity of the sodium acetate, 0.096. We're going to do the same thing for the ammonia. You okay here? Up to here, you okay? We're going to do the same thing for the ammonia now. Okay, for the ammonia, this is the acetate buffer. I can call this acetate buffer, and I will call this ammonia buffer. For ammonia buffer, I need to find moles of ammonium chloride, NH4Cl, which is equal mass of the ammonium chloride. I am using my number, guys. My number was 1.800 gram here of the ammonium chloride divided by 53.49 gram per mole. And I get 0.3365. 0.3365. So molarity of ammonium chloride NH4Cl will equal mass of moles over volume. And the volume 0.03365 over 0.2500, and that will give me 0.1346. This is a good number. So I need to use this number. Okay, that's the molarity of ammonium chloride. That's for my other buffer. Now, need to go to the ammonia. So moles of ammonia, NH3 equal, I used 5 milliliter of the ammonia, so 5.00 milliliter divided by 1,000 milliliter multiplied by 5, and will be 0.0250 moles.
Is that top number on the bottom one? Is the top number supposed to be the volume of the NH4OH?
Yeah, this is the volume. This is how much that. What we did actually. Let me we should, if we were in the lab, we would have a volumetric flask like this. It's volume 250 milliliter, and we added ammonium chloride to it, NH4Cl, and ammonia to it. So every time, all our calculation for the molarity, the volume is the same volume, 250. Okay? All right. Now I need to find molarity of NH3 here. What will be? Will be 0.0250 moles. Sorry, here. 0.250 divided by 0.250 liter. That's the volume of the, and it will be 0.100 mole. So up to here now, you got your buffer here. You prepared your buffer, guys. If you were doing it a wet lab, you prepared your buffer here for the acid, and you find its molarity, and then for the ammonia. So you already got 2 solutions, and that's where you're going to do that measurement. We're not going to do the measurement. We're going to move to the next calculation. Okay, up to here, you can do this, right?
Question.
Okay.
For the moles of NH3, 5 milliliters?
Yeah.
Is that
That's for you. Let me look at the table here. For you,
where is that?
yeah, it's
Is that the 6?
that's the 6 for you guys.